Sorry I'm a little bit late today. Hope things are going well for you. Last time we took the if-then guy and we flipped them around a bunch of ways. I'll just do a quick review here. So we had the normal conditional, and we found out that if you take the two statements, if P then Q, and change it into if Q then P, that was called a converse. If we left them in the same order but negated them both, if not P then not Q, that was called an inverse. If we did both things, flipped them around and knotted them both, if P then Q changed to if not Q then not P, that's called a contrapositive. And we found out that what? The contrapositive was the most important one because it was absolutely 100% equivalent to the original, if P then Q. And anyway, the assignments were supposed to work on that. So let's see what kind of questions first that you would like to go through. 3.4, 1 to 53 odds was the assignment. Yes?
They're all in order. I'm confused about 17, 19, and 21. They're all kind of the same.
Okay, well, let's do one of them and let's see what happens. Let's see, in this part it says H is supposed to be honk, and U is supposed to be you love ultimate. Okay, so HU. 17. If you love ultimate, honk. Now, you're supposed to write the following in symbolic form. So, the love ultimate thing was supposed to be you, so if you, then H. So how would you write that symbolically? Just literally. Does that make sense? 19? Okay, now here it gets a little fuzzier because you had to remember this necessary thing. A necessary condition for loving ultimate is to honk. So the necessary part is the honk, right? According to the sentence. Now, I don't know if you remember, but the necessary guy always goes on the right side of that arrow. So I got to put the honk on the right side. So it turns out, let's see, this was 17. So in 19, the necessary part is the honk. It's going to look the same way. 21, what's going on there? To honk is a necessary, well, it's exactly the same thing again. See, now what we're playing around with is all the wonderful ways English can say the same thing. And isn't 21 in English saying the same thing as what 19 said? It says, to honk is so the honk is the necessary part again. So once again, that has to go on the receiving end of an if-then. Read the rest of it. For loving, yep. So ironically, all three of those, I believe, should be written the same way. And from 19 to 21, it was an English thing. From 17 to 19, it was a term thing, the term necessary. So I hope I helped. Other questions? Yes? 25. Write in symbols the converse, inverse. Okay. Honk only if you love ultimate. Okay. Let me just write that down. Honk only if you love ultimate. Okay. Now, we talked about that only if guy last time, didn't we? First of all, let me symbolize this. Honk only if, I'll just copy that, you love ultimate. I think I taught you that only if gets basically translated in order just as if it was an if H then U. So 25, the final result, was you supposed to end up with symbols? Yeah. must look like that in symbols. So that's how I'd analyze it. Get it into letters, and then what does only if mean? H only if U is if H then U. Yeah. Another is one of those special English things. What did I call it? A grammar thing or an English thing last time? Anyway. Anything else we should look at from the assignment for today? Well, we should start looking at I got a feeling, did I finish that one? Yeah, all it said was write the following in symbolic form. Okay, it looks like I finished it. I was just wondering, what is this? I don't know. That 25 doesn't look the same. So here's our new lesson. 3.5, Euler diagrams. Is that the first time I've used, no, we've brought up Euler before, haven't we? Yeah, and you're going to hear about him a little bit more, too. It's Leonhard Euler. That's how that E-U-L-E-R is pronounced. You know, yes, I did. I was just checking to see if I started my recording, and I have. Okay. Euler diagrams are almost exactly the same as Venn diagrams. So this is kind of Venn diagrams revisited. Remember how we used Venn diagrams in the chapter before this, the chapter on sets. We showed how they overlap and they intersect and how sometimes one can be a sub. So I have a picture up here. And I kind of have what, a universal set? I maybe should just mark that. You know, we've this brown thing here is looks like the universal set, right? And then I've got set A surrounding set B. Now, first look at the bottom here. Does this symbolism look correct to you? Based on this picture, is this true? What's way down here on the bottom? I'm seeing one nod. Do you guys remember what that big old funny horseshoe open to the right means? Is a subset of? So this is saying set B is a subset of set A. Does that look to be correct according to the picture? Yeah, because B is surrounded by A. Now what's new is what's on the top. Now you know what that symbol means from this chapter. It means what? If B, then A. Does that make sense? Let me put it in context for you. With pictures, this could be saying to you, if you're in circle B, then you've got to be in circle A. Is that true in the picture? If you're in circle B, aren't you not automatically also in circle A? Yeah. So, you see the connection? You can use logic to describe certain set conditions. And again, that's why I'm glad our book sets up sets right before it sets up logic, because I'm hoping you see the connection and they fit together. Well, you're starting to see where we're headed. I just wanted to show you a bunch of ways subsets are shown. You guys have seen pictures like this. We solved problems like that, remember? And here, obviously, A is surrounded by B. So I took this right out of a book. Do you see what this little 3D picture is showing? It's showing that the customers are just a subset of the consumers. Doesn't that make sense? You got all these people out there who buy goods. Which ones buy goods from our company? A subset. And what's kind of cool about that is they're showing it instead of just in 2 dimensions, they're showing it in 3 dimensions. So it kind of looks like what? Kind of like containers. Um, here's another example of sets in real life. Isn't this really just a picture of the globe? And then they put up a subset of that globe, whatever is in that sector, or in this case, that square. I mean, that's a subset too. Or, when the satellite had to be shot down, I'm sure you heard about that. Didn't that just happen Wednesday night, I think it happened. There was this spy satellite that we had up there that was losing its orbit, was coming down to Earth, and it had some kind of dangerous fuel still attached to it, some really bad news chemicals that were in this tank. And they decided, instead of letting it come to the ground and taking the risk of those chemicals getting spread, they decided to kind of blow it out of the air using one of their kind of Star Wars missiles. And the mission succeeded. I call it Star Wars because you guys aren't old enough, but when go back a few years ago when Ronald Reagan was president, he started and he actually called it a Star Wars initiative. And the idea was to come up with high-tech space weapons so that if another country was to, let's say, orbit something dangerous over our heads, that we could defend ourselves. Anyway, that's why I call it Star Wars. That's what they nicknamed it because of that era. I'm sure it was because of the movies. But anyway, they used one of those tools, and thankfully, I noticed. Did you notice they put a disclaimer up? I thought this was kind of interesting. I saw in the news that they predicted they had an 80% chance, which isn't too great actually, but they nailed it. So, and you think about it, that satellite was going 24,700 miles an hour. I wouldn't be too ashamed if you can't hit something going that fast. So that was pretty cool. But anyway, what NASA did, if they weren't going to shoot it down, they were going to put out maps like this of where they projected that the thing might land, and so kind of put out a news alert. Anybody who lives in this sector, watch out for flying space junk, stuff like that. By the way, the last time we had space junk that came back, I think it was Skylab. That goes back before you guys were born. But Skylab wound up crashing in a fairly remote area of Australia. And so I think it did kill a cow, which wasn't so great, but that was, at least no people were in any danger, and it was in the outback, so there wasn't a lot to damage out there. But anyway, this one I think was maybe going to come down in the Canadian area. That's what I heard. Okay, so we use sets all the time. So there was a subset of land where this space debris was coming down. Okay, let me explain this picture, how we use pictures to do logic. T stands for triangles. P stands for polygons. You guys remember those terms from geometry? You all know what a triangle is, of course. And what's a polygon? A polygon is made up of straight segment sides, but could be any number of sides, right? From 3 up to, you name it. Okay, would you agree that the triangle set is a subset of the polygon set? In other words, are triangles polygons? Yeah, aren't they just like one special kind of polygon? What other kinds of polygons are there? Well, 4 sides, 5 sides, 300 sides, etc. Does this make sense logically? This says, if you're a triangle, then you've got to be a polygon. Do you agree with that? I can't tell if you're just wiggling your chairs or you're saying yes. Some are saying yes. Let me ask you this. By the way, I believe that is true. What if we reversed it? Would it be true that if you're a polygon, then you're a triangle? No, you could be some non. Okay. So is it important, just a reminder, is it important to get, when you're in a statement of this type, is it important to get things in the right order? Yeah, you can't just reverse them. What did we call it yesterday when we took a statement and reversed the letters? Converse. Is a converse equivalent to the original? No. What is it that's equivalent to if P then Q? The contrapositive, but not the converse. Okay. So, little caution, you want to keep things in order. And what? If you're in the subset, then you got to be in the bigger set, but it's not reversed. Okay. Well, that's the kind of reasoning we're going on to. Now, we got a few problems with English again today. Here they are. We don't always write if-then statements using the words if and then. Let me give you some examples. It says, a baby sneezes when it gets pepper in its nose. Okay? Now, I don't see any if-then in that sentence. But actually, isn't it really an if-then statement? What is it really saying in if-then form? Isn't it saying if a baby gets pepper in its nose, then it sneezes? I believe it is. So, even though you can't see the if and the then, can you see how we could translate it into the... Okay, another one. Here's one. When you cross your eyes, I crack up. Isn't that really saying if you cross your eyes, then I crack up? Smokey the Bear wouldn't have... there's a missing word there. Smokey the Bear wouldn't have to do commercials for a living if money grew on trees. What's the if part? If money grew on trees, then Smokey the Bear wouldn't have to do commercials for a living. Why? Because Smokey the Bear could just be happy in his bear environment and pick money off of trees, and then he could go shopping wherever he wanted to. Okay, you get the idea. How about 3? This is different. All surfers like big waves. Can you see what that might be in if-then form? Doesn't that say if you're a surfer, then you like big waves? I believe it does. How about this one? Licorice flavored ice cream has a peculiar color. Wow, have you ever had licorice flavored ice cream? I haven't either. I would assume that's black ice cream then. Ooh, well anyway, I'm not sure I'd be interested in digging into some black ice cream. I think I'd want to see some chemical results on what's really in it. It looked like eating a bowl of tar, but anyway. How would you put that in if-then form? If it's licorice flavored ice cream, then it has a peculiar color. A heavy object stored in the attic of a jungle mansion may crash down upon the occupants. If you have a heavy object stored in the attic of a jungle mansion, what in the world? Is that a weird sentence? But anyway, if you had a jungle mansion and you had a heavy object stored in the attic, then it might come crashing down upon the occupants. People who live in grass houses shouldn't throw stones. I think that's supposed to be glass houses. Gosh, we got some... Yeah. Let's get that changed. Grass houses. Let's try glass. And what was the one up here? Wouldn't have to do. There we go.
Number 6 should say throw stones.
There's some pretty funny errors there. Sorry about that. Thank you for the corrections.
It still says throw stones.
Oh, so I changed throw.
But corrected it, yeah.
I would hate to be hit by a flying throne, too, wouldn't you? People who live in glass houses shouldn't throw stones. There we go. Finally. Okay. I think we got it. Well, how would that... we haven't done that one yet. what? If you live in a glass house, then you shouldn't throw stones. And no ghost has a shadow. Oh, be careful on this one. No ghost has a shadow. How would you put that in if-then form? Right. If you are a ghost, then you don't have a shadow. You see how that's a little bit tricky? Part of today's work is you're going to have to take some non-if-then, some statements that don't have the word if or then in them, and like rethink them as if-then statements. Because once you know the if guy and the then guy, then you can apply the rule that I taught you, and you can go from there logically. Okay. Well, let me just, on this page, I'm only going to show you one thing. Where we're headed in this chapter is eventually I'm going to teach you how to analyze what's called an argument. And an argument doesn't mean two people are sitting there being angry at each other. An argument in mathematics means a set of statements that you put together and draw a conclusion from. Okay? Here's an argument. And so it's like this is one statement, here's another statement, and then this bar says, therefore, and then you have your kind of your conclusion sentence. And eventually we're going to get, that's called an argument. And by the way, that's a therefore, and this little triple dot, have we talked about that? Yeah, that's another way of saying therefore. Okay. So let's get off this example page. All right. So first of all, one more time in the picture, I've got circle B surrounded by circle A. Would you agree that this is true? Set B is the subset of set A. And is this true? If you're in circle B, do you have to be in circle A? Yes. Okay. Could I reverse it? There's a huge clue up here. I've already drawn an X through it. So, no. Okay. Now, example 1 in your book. You've got to look it up so that this makes sense. It's on page 147. Argument. All men are mortal. Second statement. Socrates is a man. Therefore, Socrates must be mortal. You see that? Little page 147. Now, I've made a picture of it. All men are mortal. Would you agree with my drawing? All men are mortal. So in other words, if you're a man, you got to be mortal. Right? If you're in this circle, can you possibly escape this outer one? No. Okay. Now, where does Socrates go? Second statement. Socrates is a man. So Socrates is this little X. And doesn't he have to be in the men's circle? So what do you think about the conclusion? Does Socrates have to be in the mortal circle? Yeah, he's got to be. All you got to do is open your eyes and look. So do you see where this diagram helps you see that? Euler diagrams, then, can really, help you visualize a logical conclusion. And this lesson is all about that visualization. I got to just tell you, the next lesson, we're going to show you, if you don't like using the visualization, I'm going to show you a truth table way to do the same thing. And honestly, the truth table way is just a little bit more certain because you can look at every single possibility. But this, I don't know, what do they say? A picture is worth 1,000 words. There's some truth to that. Sometimes a diagram will take an issue and you'll go, oh, it's obvious. And you just be able to see it. Like here, Socrates is in here. Yeah, he's got to be in the mortal circle. Okay, the other thing I got to warn you about is the statements in this chapter are kind of stupid. Okay, you probably noticed that already. And by the way, I forgot to warn you. You probably noticed this. There's a lot of beer in this book. Did you notice that? I think there was beer in the last assignment, and I didn't even give you a disclaimer. So anyway, just beware. There is a bunch of beer. And there's a bunch of strange statements coming up in this. But try to look past that. I had some students going, they were like, wow, Socrates is immortal. No, he's not. He's dead. And they got into a big philosophical thing over whether that was a good statement, and that wasn't the point of the lesson, okay? It was just a matter of, did we follow correctly from each statement to the conclusion? That's what we're looking at. Okay. Well, on we go. Example 1, we already did. Example 2, look at it in your book, please. Example 2 is on the next page, and it says, all foreign cars are expensive. And again, just look past it, okay? We're not trying to knock on your foreign car if you have one. It's just the way they had to start with, they had to come up with something. All foreign cars are expensive. Second statement, my car is expensive. Therefore, my car must be foreign. Well, let's look at it. I made a drawing. All foreign cars are expensive. So do you see how I put the foreign car surrounded by the expensive circle? So FC, foreign cars, are surrounded. Would you agree that all foreign cars are expensive from my picture? Yeah, because everybody in the FC circle has to be in the expensive circle, right? Now, what does the second statement say? My car is expensive. So where do I put my car? Somewhere in the E circle, right? Well, couldn't that be out here or in here? Is this looking familiar? Have we done something like this before? Seems like we did something like this in sets, didn't we? But anyway, would you agree that both of these are possible? So what do you think about the conclusion? Does my car have to be a foreign car? No, it could be over here. So is that a valid argument? No, that's an invalid argument. Did I ever tell you the invalid story? Sorry, this is just a little bit of humor I'm going to interject. True, this is true, this actually happened. In the old days of computers, when they weren't so graphic in operation, they were more text-based. You'd have a little prompt and you'd type in a command in text and then you'd get a response in text. They call that DOS, Disk Operating System. But anyway, in the original MS-DOS, if you typed in a command that it didn't understand, it would reply and say, invalid statement, please try again. Okay? They were trying to say, I don't know what that means. You must have typed something that's not in my library. Okay? So you get it. Here's the funny thing. The word invalid is spelled exactly the same as the word invalid. A true story. A woman was so ticked off that she got that response. She wrote in something that said, invalid, and she sued Microsoft for calling her an invalid. I'm not kidding. She did not win the suit, but isn't that weird? She was like, no, that's not invalid. They called me an invalid. They can't do that to me. They destroyed my personal career. Anyway, weird, isn't it? So on we go. Strange but true. Okay, in the box, I'm just trying to show you how an argument is set up. You got these statements, and then you've got the therefore, and then you've got the conclusion. We have a name for these statements above the therefore. They're called premises. Premises. So it's like premise 1, premise 2, and the plural of the word premise is premises. So it's kind of like you're given information. You remember in the old geometry days, they would say to you, given an isosceles triangle ABC with side AB equal to side BC. Those were like the premises. Prove that, I don't know, triangle ABD is congruent to triangle DEF. That was kind of like the conclusion. So in a way, the premises are like the given, and the conclusion is what conclusion you can come to. So just some terminology. Yeah, let me just erase these and we will start over. And what these are is some examples from the book. So let's take some from the book now. Here we go. Now, when you look on page 151, I apologize for numbers 1 through 6 because they are so ridiculously simple, I almost have to apologize to you. Okay? There's actually not much to do there. They're saying, can you tell me which sentences are the premises and what is the conclusion? That's like, which sentences are above the line and which are below? I mean, there's no secret there. That's all there is. Okay, let's get out of that part. 7 through whatever says, use Euler diagrams to tell me the validity of the argument. So let's do one. Number 8, all students are studious. Okay, so I'm going to make a diagram, right? All students are studious. So does that look right? Yeah, because if you're everybody in the student circle has to be in the studio. Okay. Statement 2. Mr. Smith is studious. So where do I put an X for Mr. Smith? So it could be in either place. Absolutely correct. Okay, does that tell you something? Guess what? The conclusion usually in a case like that is false. What's the conclusion they want you to come to? Therefore, Mr. Smith is a student. What do you think of that reasoning? He might be, but he might not be. So can you conclude that he is? No way. So that's called, and now I gotta tell you guys something. When you've got this diagram on your paper, that's excellent. But you're not really done with a problem until you say valid or invalid. Okay, in other words, tell me, what conclusion did you come to? I can't tell you how many papers I have collected or corrected where people don't put their conclusion down. And I'm like, I think what they're saying is, hey, this is going to be a tag team with you, Professor Below. So they're like doing a high five. You take it from here now. No, I want you to finish it, okay? So please don't forget to write down valid or invalid. Next one. Let's do number 10. So this is number 8. Okay, how about number 10? Number 10 says, all students are dedicated. Wow, we got all these nice things about students. Cool. Okay, so all students are dedicated. Is that picture correct? You probably noticed by now. Where does the all thing always go? In the inside, right? Yeah. Okay, what's the second thing? All wealthy people are students. So now you got to help me. Where do I put the wealthy people? Yeah, and that's a group. So I'm going to draw another circle. They got to be inside S, don't they? So I should have made myself a little bigger one there, but okay, let's have, so that's really, wouldn't that be the wealthy people then? All wealthy people are, all right, cool. Conclusion, all wealthy people are dedicated. What do you think? If I drew it right, that has to be true, doesn't it? Aren't all the wealthy people, don't they have to be in the dedicated circle? So that definitely appears to be a valid conclusion. And doesn't the picture help? It should. I'm hoping you're seeing that. Okay, again, let me erase. We'll start over here. Strange looking diagrams. On we go. How about number 12? All football players are muscular. Okay, so there's the football players. and they're all in the muscular circle. Statement 2, Jack is muscular. So where do I place Jack? Isn't that one of those, just like before, where Jack could be in either place? How about the conclusion? Does Jack have to be a football player? No. Can you see that that's invalid just by looking? On we go. 14. Here we go with the beer. Okay, sorry. Some student, oh, and this is different. Some students drink beer. Does that make sense? Some students drink beer? I'm sorry, we just had somebody walk by and look in and go. Looking at that. This is a class, this is an art class, he probably thought. Okay, some students drink beer. What's the second statement? All beer drinkers are dangerous. Oh boy. Now, where am I going to put the dangerous circle? Now, this one gets more complicated. First of all, I'm going to change colors. So here's my beer drinker circle. I didn't change colors at the right time. I mean my dangerous circle. That could be one of them, couldn't it? But couldn't the dangerous circle also look like this? I'm going to call this one dangerous 1. I'm going to call this one dangerous 2. Can you think of any other places where I could draw the dangerous circle so it still surrounds the beer drinkers? I think I got the main scenarios, don't I? So do you see how both of those could be valid? Yes?
You could draw a circle that's identical to those who drink beer.
That's true. I could draw it right on top of drink beer. I'm not going to do that one because then we won't be able to see it, but you're right. Absolutely correct. So there's actually 3. Now look at the conclusion. All students must be dangerous. I'm sorry. It is funny. Now, you got to answer me. Now, be careful. You're probably going, uh-oh, now which D circle do I use? And the answer is you got to kind of keep both of them in your mind. Okay? Let me ask you this. Would all students be dangerous if I use D2? Yes. How about if I use D1? No. How about if I use D3, which Matthew gave us, which is right on top of DB? No. So can I say that all students should be dangerous? No. The only way you can say that is if it's true all the time. So do you see why that time I needed more than one drawing? Because for all beer drinkers to be dangerous, I had to have dangerous surrounding beer drinkers, and that can happen in several ways. Okay, sorry about all the beer. Okay, on we go. 16, all hippies have long hair. Yeah, some of these are just bizarre. Okay, so there's hippies and have long hair. I'll use HLH for that. All hippies have long hair. Second statement, some athletes are hippies. Some athletes are hippies. So I have to draw an athlete circle that partially crosses the H circle. Now this could be drawn in several ways. Okay, here's one. That might be an athlete circle, right? Some of them are hippies. Couldn't I have drawn an A circle like the athlete circle like this? I think that's it. You got another one in mind?
Technically, since it says some,
Oh, it could be right on the H again. Yes, because the word some could be, it means at least some. You're right. Okay, now, look at the conclusion. What do you think? Some athletes have long hair. If we use Matthew's, the answer would be invalid, right? Because weren't you going to say that the athlete circle could be right on the H circle? Oh, they're still, excuse me. They still have long hair, don't they? So it's valid. Thank you. Didn't open my eyes completely. Okay, one more beer question, number 18. All beer lovers like Schlitz. I don't know, some of you probably have never even heard of Schlitz, but it's kind of an old Milwaukee thing. Okay. Okay, all beer lovers love Schlitz. Second statement, all people who like Schlitz get drunk. I don't really need to draw that any other way, do I? I don't think so. So now, what's the conclusion? They say in here, all beer lovers get drunk. Now, it's stupid. I mean, obviously we're not really saying this, but according to that argument, doesn't it appear to be valid? So again, whatever you do, don't take this assignment and say, Mom, my book has offended me, or it's offended Uncle William, and says he's always a drunk because he drinks Schlitz or something like that. Don't take any of this personally, okay? Or those of you who own a foreign car, you're fine. There are some weird things as you go on, and there's more beer, I gotta warn you. So be careful of the alcoholic beverages. Make sure you understand the student policies and all of that, but I think they've given us permission to do this assignment. Yeah, pretty corny, I know. All right. 1 to 37 odds, I think. I got to double check. We're going to have to go online. We'll just double check and make sure. Oh, it's different in here. 7 to 37 odds. So in other words, I'm not going to embarrass you with 1 through 6. 7 through 37 odds. Okay, have a nice weekend.